Hello, everyone. It's a pleasure to be here. It's an honor, and to you on the other side of the screen. I know how challenging 2020 has been, so thank you so much for taking the time to listen to this talk. I hope you enjoy it and that you remain safe and healthy. Today, I'm going to talk about modern solutions. My name is Belen Curcio, and I'm the director of solutions at Vercel. In case you are not familiar with what Vercel is the fastest way to deploy front-end applications. We enable collaboration by giving front-end developers comprehensive tools to build high-performance websites. Now to talk, what you should expect from this talk. We're going to set the ground and foundations of this talk by going over some background about me and also a historical overview of modern web applications, with some conclusions and characteristics about the landscape of modern web applications, and also where it shines and where it does not, and with its pitfalls and its challenges as well. So after that, we're going to jump right into what the solutions team does and why it is important to embrace a solutionist mindset, quote unquote, when building modern web applications, and some techniques later to build resilient web applications and stay on track when doing so. So a brief description about my background is I joined Vercel over a year ago. Prior to that, I joined Vercel as a solutions architect. So I work closely with clients to help them achieve scalable solutions with Vercel, and also with multiple technologies as well, not only Next.js, but Nux, and SpellKit and more, and many more. Before joining Vercel, I was a lead front engineer at Mozilla in a project called the Core Project, and we worked on building an open source tool to help improve online communications. This project was a collaboration between the New York Times, the Washington Post, and also the Knight Foundation, and it was acquired by Vox Media. Prior to that, I was a software engineer at RGA. I think this is a boot camp. This is the mother of all agencies. I got to work with the big players of commerce, Johnson & Johnson, PwC, Equinox, RGA.com, Nike, and many more. I'll go over the stack later. And prior to that, I was a software engineer at PFA. If you're not familiar with those letters, this means that I work for the police and the government in Argentina, and particularly with healthcare and security systems. So I went over all of this because I'm going to use these timestamps throughout my career to elaborate on an overview over the history of front-end architecture and also web architecture, the entire landscape. So I'll skim a bit through technologies here, and I might be missing some of them, but bear with me. So in 2011, the current stack was this. jQuery and MooTools, of course, they were magnificent tools to manipulate the DOM. They enabled and unlock a lot of interactivity. So they were pretty significant in the way they shape how we do front-end today. And on that realm as well, we had PHP, with a lot of frameworks like CodeIgniter, CakePHP. They remain pretty relevant in the way we build helpers and functions. Ruby on Rails as well, that it remains highly relevant in the way of how we see model view controller and how we understand and architect technologies and applications. And on the enterprise level, I worked a lot with Java and Oracle and PLSQL. This was the current stack for enterprise, and I think it remains to be in some places. 2012 and 2014, we were starting to get rid a bit of spaghetti code and all the technical debt that jQuery added. That quote unquote jQuery added, because jQuery did not add that spaghetti code. But you might remember Backbone and as a rendering layer and underscore templates. You had this way of interpolating templates and getting those variables in. So it was pretty smart. We also had Meteor, and this was when we started to think about components, dependency injection, and scope. It was really challenging not to collision with other components, with other scopes, right? So yes, so we all, this was when Angular 1, V1 was born. And it was so revolutionary, if you remember the double binding, when the demo was to write in an input and it got automatically updated on the front end side. And also the root scope, it was pretty revolutionary. It pretty much laid a lot of the foundations and on how we do front end nowadays. And again, on the enterprise level, we had ASP.NET and Sidecore CMSs. And I don't think all of us are completely familiar with it, but I worked a lot with Sidecore CMSs, and they were really hard to update. They were really tough. They had a building process. It was really hard. And also Drupal and WordPress as well. And 2016, was pretty much 2015 was pretty much the year of React, right? We all know what React means for us front developers, and I think and we all know we are going to continue to study its implications of the paradigm that they created on how to architect components and build front applications. And the same with GraphQL. GraphQL empowered a lot the front developer into. So the bundle.js that we were shipping was one thing, but the data that we were shipping is another. Are we shipping too much to the client? So GraphQL was also, in my opinion, really important during this time. And Apollo and Relay were addressing issues about how to manage state and a lot of things. So this was just starting to get traction. So the landscape pretty much looked like this, and now we have these quote-unquote things called meta frameworks, Next.js, Next, Svelte, that in reality are not meta, are just layers in front of rendering engines, if I can say so, or frameworks actually that help and address modern web problems, and also with microservices and headless API. But if you ask me, I think we are meeting a critical piece of web history. And I think it was around 2004 where the stack was this one. We had Microsoft Front Page, Dreamweaver. For the forums, we have something called B-Bulletin, and also Nuke PHP. Anyone? It was a pretty golden era of the web, if I may say so. And on the server side, we have this wizard, cPanel and Fantastico for interactivity. We had Shockwave and Flash, and behind the curtains, we had the LAMP stack, right? So I put that DNA there because I think that if I get a 23andMe test, DNA test, this is pretty much what you'll find. And I believe this stack is key to understand our present, and it will give us insights to understand the future. So let's break it down a bit. Remember that this was before jQuery and MooTools. So this was pretty much the 2004 web developments, right? So for WYSIWYG editors, we have the entire development experience handled by the editors. It was really smooth, and it was a real-time experience. Like you could preview your pages and you can ship them like really fast, significantly fast. This was 2004. So you had complete ownership over the file system by just hitting save as. So your compile process, your building process was the save as. So here you got your HTML and CSS files, and those question marks are the interactivity piece. So here you have your static files, and most of the interactivity back then didn't came from JS. It came from Flash. And if you ask me, this could be pretty controversial, but I think that this is where frontend as a career path began. Here's where it was born. And also with that, single page applications, you were able to, I'm not sure if everyone is familiar with it, but just to level set, you were able to hook an SWF file, a Flash file, to a website, and that was shipped to the clients, right? You had the loading, the spinner was not a thing, but then you had the loading bars. and you could enjoy a really rich interactive experience with Flash. But the problems remain the same. You have bloated SWF. Flash-based projects were delivered with the Shockwave Flash, and it was proprietary. So you needed a plugin to run it. We all know it was shut down just I think recently. So if you wanted to add JS to add some interactivity, you could do it with a little help of JavaScript. And through FTP, or client actually, this is file transfer protocol, you can transfer to a public folder. I put server there because it was an actual server, but you knew very little about this server. You just knew that you were deploying to a server, and that was all you needed. So this is beautiful, in my opinion. And the beauty of this stack is that this was the view of the webmaster's perspective. You had your layout, you have some modifications. Just take a look at this UI. This is Dreamweaver. And also that tiny icon that I'm highlighting there, that red, it's a world. You were able to ship by pages. And this was amazing. So this resembles pretty much what we want to achieve nowadays, shipping incrementally and all that will go in depth. So if you didn't like Dreamweaver that much, you can go with your own FTP client, and it was that easy to deploy websites that you can just drag and drop a folder. So yes, this was incredible. So the developer experience was incredible. Deploys were pretty instant. It was small by default unless you added images and SWF files and all that, but we didn't have a way to compress them efficiently, and we have full ownership over the whole pipeline process. But these apps were limited. It was pretty limiting the platform. Multi-page was hard to maintain. Remember that there was no concepts on components, and also no concepts on dependencies and all that. No encapsulation, no modules. Anything. It was a really big global scope. And above all, I think the most important is that there was no focus on the user. You have, a fun fact about this is that you have the footer below your web page, and you can put something like, if you cannot visualize this web page correctly, just go and download Chrome again, or Microsoft Explorer again, or Mozilla, Netscape. And it was the developer actually asking and demanding for the right user instead of the users demanding for the right application. I think it was amazing actually. Okay, so why did we move past this? This requirement, this looked perfect, right? So why did we move past this? So the requirements started to increase, and more limitations appear, right? And it was mostly related to state. So we pushed all those requirements to the server. DB, CMSs, monitoring, everything, cron jobs, everything to the server. And we ended up with full server implementation that did a lot of things. And we ended up with this model, right? The traditional web standard model nowadays. This is a huge simplification of what it was, and there could be a lot of permutations over this, but in short, it is the same. You have the client where you have your HTML, your CSS, and your JS. There could be portions that could be server-side render. There could be portions that cannot be server-side render, so you can push some assets to the CDN. But this is not CDN ready. Below you have your server, and also sometimes you can also build multiple servers for your web server and your API layer, and also. But yes, in short, it was a big server that did a lot of things. So this full server implementation, I'm sure most of us are aware of it, has a lot of problems at runtime. So if we put a lot of tasks into one server, we create a single point of failure, and there's no sort of separation of concerns. So the moment something blows up, imagining that your web server blows up here, everybody pays for it. Everybody gets taxed by it. And if you're lucky, you return a 500. But most of the time, this is not what's happening. This is not what is going to happen. And let's be honest, sometimes it's really difficult to recover from this. We'll see that some industries will not forgive you for this. This is not CDN ready, right? You cannot ship this to the CDN, and this is really hard to scale. You can have a lot of money, of course, so money could solve it, but it's really costly. If you open multiple regions across the globe to spawn multiple servers, most of them could be idle, and if one of them exploded at runtime, it will be a matter of seconds until the other region also explodes. So you need to update them all at the same time and more, and so on and so forth. So this is costly. It stresses developers, and yes. So this means longer deploys and delays the time to production, and it's really challenging to test this, right? It's really challenging to test this because this model generates a significant amount of side effects, right? We have modifications by the web server, modifications by the API, modifications by the DB. And so if we want to, this is an impure implementation. So that's what I meant with side effects. So if we want to define a functional model of a web application, we'll go for something like this. So if we can create a functional model of a web application, and it will go pretty much like this, where you'll separate your web apps into two entities, right? On one side, the data, and the data accounts for the visual components and the interactivity. And on the other side, the UI, so the UI accounts for the visual components and the interactivity, and the data accounts for the content and the app state. And if we describe these two entities, then we can infer that the UI is a pure function of the data, and it returns a static representation of your application below that, so of a given app state and content. And if we think a bit over that, having a static representation of your application means that we have Jamstack, right? This resembles the Jamstack model. So I think we are pretty familiar with the Jamstack model, but if not, Jamstack is an architecture that is fairly predominant in web applications nowadays. It's portable, it's secure, it's performant, and it has an incredible good developer experience, right? Sometimes if we want to add more batteries to it, we can switch that API part with microservices or use them in conjunction, right? So, my honest opinion, I think Jamstack really empowered front-end developers into understanding the constraints when building web applications. We regain knowledge of the whole pipeline. So on one side, we have the traditional web standard model that does pretty much everything. And on the other side, on the right side, we have the Jamstack that is too limiting. So on the right, with the traditional standard model, it gives us all the ownership that we need. We pretty much can put everything in a box, and we know what to modify. We are not logged in, but at runtime and at scale, it's really hard to maintain this structure. But at a smaller scale, it's amazing. So we want all these benefits, and also we want all the benefits of Jamstack. Jamstack, it's pretty perfect in terms of how atomic, how performant it is, how secure it is, because it doesn't ship with much thing. So what we've seen at field is that at a higher scale, the entire picture looks a bit different. It looks a slightly more hybrid, right? So we want the benefits of the traditional standard model, and we want the benefits of Jamstack, and we want to improve that. So if we want to describe what a hybrid model is, we know that it needs to fulfill certain requirements, and among them, it needs to be secure. It needs to be available. It needs to be up to date. So this was one of the most criticized things that Jamstack has. The issues of the statics, right? Because of its nature static files, we need a way to maintain that compromise with customers enabling personalization, there are a lot of techniques that we are kind of limited with Jamstack. So the hybrid model should fulfill this requirement. The same with performance, right? It needs to be performant. We need to leverage the CPU usage and also the network usage and understand what we ship. And we need it fast. If there's something that we learned throughout this 2020 is that we need to update things fast. We need to iterate fast, and we need a way to provide a solution to our users. So there are a couple of frameworks that embrace these hybrid approaches. So we have Next.js, my favorite, not biased, by the way. No, actually not biased. I gave a talk in 2016. It's Next.js is amazing. Node.js, of course, and Svelte kit. So these are the frameworks that build upon these characteristics, the frameworks that want to push the web forward, right? And grab the best from all the standards. But they won't do everything for you. That's the real thing. If you have a hybrid approach, then you'll need some server-side rendering, and that server-side rendering will run something. And if that something is a lot, then there's no framework that can help you aid that. You're again in the same issue. So I'm a firm believer that the hybrid model, we're letting also our users dictate some of our product, and also dictate some of the architecture that we are going to end up building. So this is what we try to achieve with the solutions team. We work closely with our customers. We share good practices. We audit code, and we try to understand the context to provide the right solution, and also to achieve all these characteristics that I was just mentioned, to go where the web is going, right? So solutions vary based on industry, audience, and also the nature of the application and the product. By knowing these aspects, we can shift with strategies and recipes. So the solutions team tasks are around these sort of things. We help customers deliver rich experiences, improve web metrics, decrease technical debt, and shorten time to production, create demos and proof of concept, explore complex cases of web applications at scale, my favorite, and some code audits, right? So how do we do it? As I just mentioned, over that whole overview, if you didn't realize, there's no silver bullet. Today, we are not going to have that isomorphic, universal framework hybrid that is going to provide everything you need. You need a workflow. You need a way to build a scalable and customizable solutions, and you need a way to stay on track with them, right? So I'm going to share a bit about the workflow and the playbook that the solutions team uses. So as I mentioned, the solutions team works closely with the customers, right? So we primarily focus on having a rich meeting where we get to know the whole team. We identify squads, marketing, content, growth, tech leads and devs, and also the proficiency and the size of the team. This will significantly change how we deliver a solution or how we provide a solution. So, for example, if the team is not that big, we cannot propose something that they will not be able to achieve. And the same, if there's a team that is highly populated with content, then we might shift for something less technical and go for something that a headless CMS could do. So we try to leverage that pretty quickly. Also, we have an internal questionnaire to run these meetings. But first, of course, we go over the outstanding issues, right? They take precedence. Then we jump right into an analysis. We go over the industry, and we try to cover it all, right? We go over the industry. Here could be retail, news and media, financial, travel as well. And this analysis, we like to cover it all, right? Because it's important. This pretty much will dictate most of the architecture, believe me. The audience, we try to segment the audience. Audience in our industry are pretty tight tightly coupled. They go hand in hand sometimes. There are some, we'll explore in the next slide, there are some traits that the audience shows depending the industry, and that affects the product, the tech product. So then we go over the product that the customer has. So some product considerations and technical aspects. Analysis over the industry. So as I mentioned, each industry is pretty different. They vary a lot. And also the solutions vary per industry. So retail, for example, is highly seasonal. They have Cyber Monday, they have Black Friday, Valentine's Day that is coming soon. So this means that you need to prepare for that DDoS that your own users are going to throw at you, right? And you need to architect accordingly. The same, like you can strategically and programmatically trigger to build the most red products or the most heart-shaped products of your retail store, right? There are a lot of things that can dictate that. So news and media. News and media is pretty subject to, for example, elections day. Elections day, the same. There could be one day every 4 years, depending when elections attacks you, and that means that a lot of users from the whole globe are going to DDoS you again. It's pretty subject to breaking news. You can be viral in seconds. They have a patterns to get readers become subscribers. There are a lot of patterns of this industry, ads, paywall, and above all, they need to generate engagement. So there are a lot of aspects here that need to be taken into consideration. For financial, they are pretty sensitive with real time, right? The loyalty could be breaking into seconds, the customer loyalty, if you don't react accordingly. So this is when we need to simulate a real-time thing. Sometimes this doesn't mean server-side render, but it needs that the UI and the content needs to be as updated as possible. It needs to be trusted. So this industry is really subject to black swans, right? It could go viral in no seconds. Something like GameStop stocks and IPOs could throw you down in seconds. And so this is unexpected DDoS again, and you need to be prepared to scale quickly. So for travel, this varies. This is pretty similar to retail, but again, it's more of a personalized experience. So they have pricing strategies, booking flows, and personalized and relevant experiences. As I mentioned, it's pure. It follows a lot on the recommendations realm. So now, switching to the audience pretty much dictates the product, I believe, and also a lot of the tech considerations, as I just mentioned. So for retail, there's a low tolerance on price changes, right? And what this could mean is that imagine that a user wants to add something to the cart, and that cart is not correctly up to date. And that could mean a rage quit or not coming back, or even so, sometimes they continue to do that and they know all the bugs of your applications. So these are really low tolerance on price changes and also on stock and stuff like that. So if you let the user dictate your product, you'll add some polling of updates, or you'll you'll let the user know with optimistic updates or something that something will change, right? So you don't surprise them with bad news. News and media, they need to generate a lot of engagement through community. So there's a lot of things that a media needs to be aware of. So they have ads and paywalls and bots. So it will dictate how you architect stuff later on. So at Coral project, we had a lot of issues with bots. It was with GPT-2 and GPT-3, it was really hard to detect if you were having a human conversation or not. And if the human knows that the conversation has been violated by a simulation, by a bot, then they will likely leave. If there is self-filled with insults, then they will leave. And so you need to protect your users here. Financial. as I mentioned, this is a pretty sensitive audience. There should be no UX queues. You cannot queue a user. They need to be attended quickly. They are dependent on real time and optimistic updates. And here on the right, we have target and segmentations, and this is pretty standard. Which part of the globe you get most of your visitors, right? So it will determine, for example, where you're going to put, in which region you're going to put your serverless functions, or if you're going to let something address that for you. And also the devices, right? So as I just mentioned, the audience in the industry can determine a lot of your product, and here you can determine the rendering strategies. We can predict the rendering strategy with it. So this means that we can switch from eagerly pro-rendering certain pages to lazily pro-render ahead of time, based on what we learn throughout the analysis. Then we switch to product. These are detailed considerations about product, mostly technical aspects of it. If it's a single page application like Figma, if it's a multi-page application like a big e-commerce or news site, if it's multi-tenancy, has several stores, or if it's a micro front-end application like a commenting platform, for example, like it's injected. So we jump right into the fun part, the solutions. So having all that analysis crunched, we have 4 pieces to grab here. We have performance first. So what is fast? We define here, right? So there's the real performance. There's 2 sides of how performance is for a user, right? There's the real aspect of performance, and there's a perception of performance. So we always recommend to focus first on the latter, so you have time to work on the other ones. So some common tips here will be this: check your third-party tags, add some trackers, right? Focus on core web vitals. Like let this be your fitness function, your treadmill. Like mostly, this is my honest opinion. I really like to focus on time to interactive because I want my users to be able to click fast, and also to handle something called uncanny valley, right? Feel free to delve into that later, but you want to be able to provide an interactive website in a short time, right? In a short period of time. Lazy load based on user interaction. Here, if you use, for example, Next.js, you could use the image component, and that could also aid to solve a lot of issues with images. Check for the usage of the CPU, avoid unnecessary re-renders, and debug systematically. So if you use reactive tools, if you're running a React platform, then you'll be able to find unnecessary re-renders. Don't ship to the client what the client won't use. So don't abuse this power. We know that they can run everything. I don't know how long it will last that we can ship everything to the client, but don't abuse it. Analyze your JS, right? We know that bloated JS are a problem. So I think a half of websites ship with more third-party code than first-party in the same bundle JS. There's a lot of overhead shipping unnecessary and unneeded legacy JavaScript, and that accounts for a huge amount of internet bandwidth. So check also which ECMA are you transpiling to. I think that ECMA 2017 it's a good sweet spot, if I recall correctly. And images and web fonts, check your assets as well. On the solutions architecture side of things, we build ready-to-go proof of concepts and recipes. I think you'll be able to find this on the solutions section in vercel.com. And if not, follow me on Twitter at Ogbel. I will happy to share multiple recipes about this. So here we tackle solutions with external API, recipes with helpless providers, databases, monitoring and logging, and microservices and caching strategies, right? So in the good practices that we like to share, this is a tiny snippet of it. I'll say that commit to a certain level of performance. So you keep on trying to reach that carrot systematically. If you are on Vercel, you can use Next.js analytics, and if you're using Vercel, if you're using Next.js as well, we're about to ship a lot of analytics. I'm not sure if I can disclose this, but stay on track with this. Build a progressive loading experience. So not all of your users are going to experiment your web in the same way. So I think put some work into it. You'll find a lot of things about your product. Use feature flags. So at Vercel, we work a lot into not letting you blow up in production. So if you use feature flags, I think it's also a good way to stay on track. Don't blow out in production and try to ship a lot. We use it as well. I use it in my personal projects. Build incrementally. Know your audience, know your industry, and plan your rendering strategy. You use all the hybrid capabilities. Use the tools. Let the tools work for you, not against you. There's a vast world of open source tools that are there just so you can grab them. So don't be the team that focuses way too much into building a brick. Focus on building the best wall. Make yourself independent. This is kind of lessons learned from infra, but set it up to be restarted in no time everywhere. No one likes the feeling of locking. And build resiliency. Default to another source of data if you can. So this was pretty much it. You can now ship and deploy your product, and you are here with now a good model to keep on iterating and building amazing modern web apps. So you can keep on iterating, analyze your industry, audience changes, and performance and architecture, and more. So I'll repeat this. Don't be the team that focuses way too much on the brick. Work on real case scenarios, work on edge cases. Be the team that builds the best wall. Focus on reality. Let the problems guide you. Work on real case scenarios. And this, my favorite is edge cases. You never know when they're going to hit you. And stay on track. The ecosystem is constantly changing, and we need to stay up to date. And finally, last words. The web is really complex, but enjoy it.